In this lesson, we will examine questions where the distance between two traveling objects is either shrinking or expanding. In the example shown here, Yolanda and Bob are walking towards each other, so the gap between them is shrinking. Our goal is to determine how many hours it will take for them to meet. To answer this question, let's see what has occurred after Yolanda and Bob have both traveled for 1 hour. Let's begin with the two of them in their original positions. Now after 1 hour, Yolanda will have traveled 4 miles towards Bob, since the question tells us that Yolanda's walking speed is 4 miles per hour. Similarly, after 1 hour, Bob will have traveled 3 miles towards Yolanda, since the question tells us that Bob's walking speed is 3 miles per hour. So after 1 hour, we can see that Yolanda and Bob are now 35 miles apart. In other words, the distance between them has shrunk 7 miles during 1 hour. We say that the shrink rate is 7 miles per hour, and we get this rate by adding the walking speeds of Yolanda and Bob. Now our goal is to determine how many hours it will take for them to meet. So if Yolanda and Bob were 42 miles apart when they began walking, we want to know the time it will take for the distance between them to shrink from 42 miles to 0 miles. To calculate this, we will use the time formula. So the time will equal the original separation distance of 42 miles divided by the shrink rate of 7 miles per hour. This equals 6 hours, so it will take 6 hours before Yolanda and Bob meet. Okay, now let's try another question. Here we are told that Sabby and Gwyn leave the same location at the same time and head towards Townville. Sabby travels at 40 miles per hour and Gwyn travels at 30 miles per hour, and we want to determine the distance between them after 4 hours. So once again, let's see what has occurred after they have traveled for 1 hour. Since Sabby travels at a speed of 40 miles per hour, she will have traveled 40 miles after 1 hour. Similarly, since Gwyn travels at a speed of 30 miles per hour, he will have traveled 30 miles after 1 hour. As you can see, the distance between Sabby and Gwyn is expanding since they began at the same place and after 1 hour they are no longer together. We can calculate the expansion rate by subtracting Gwyn's distance of 30 miles from Sabby's distance of 40 miles. So after 1 hour, the two of them are 10 miles apart, so we can say that the distance between them is expanding at a rate of 10 miles per hour. Now our goal is to determine the distance between Sabby and Gwyn after 4 hours. To do this, we will use the distance formula. So the distance between them after 4 hours will equal the expansion rate of 10 miles per hour multiplied by the time of 4 hours. This equals 40, so Sabby and Gwyn will be 40 miles apart after 4 hours. Okay, let's summarize. For questions with shrinking or expanding gaps, first observe what happens after 1 unit of time. Then use this information to determine the rate of expansion or shrinkage. Finally, apply this rate to the question.